Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tip channel. Please like, share, and subscribe to get regular updates on new episode releases. Let's get started. Welcome to episode 4. I'll be covering questions 16 to 20 in this episode. For previous questions, please refer episode 1 to 3 of this series. Let's get started. Question number 16, a business operates an application that collects data from its consumers through various Amazon EC2 instances. After processing, the data is uploaded to Amazon S3 for long-term storage. A study of the application reveals that EC2 instances were inactive for extended period of time. A solution architect must provide a system that maximizes usage while minimizing the expenditure. Which solution satisfies this criteria? So what do we have in terms of problem description here? We have an application which has EC2 instances, multiple EC2 instances. It is writing data to Amazon S3. However, most of the time EC2 instances are idle. And because they're idle, but they're still being in use from an AWS usage perspective, you are incurring cost. So this is your problem description. EC2 instances are inactive for an extended period of time, and we need to solve it. As a solution architect, you need to solve this problem. So how do we solve this problem? Again, as a solution architect, you have complete liberty of making minor adjustments or making big changes to the solution if that's what you need. Now, if I have to solve this problem, I can see there are a lot of requests queuing up. I would like to make this solution an event-driven. So depending on the request you get, we can trigger a particular instance of compute and then write the data to S3. Now, that's my first point of time. I would like it to be event-driven. And if I'm doing event-driven, I don't want to unnecessarily use compute, which is instance-based. I would go for serverless. So these are the two things I would see, and you would have a similar pattern of problem scenarios in different questions as part of solutions architect, where you are either accepting a lot of requests and doing a certain action, and an expectation is this doesn't have to be a synchronous update. If that's the case, then you can always go for a event-driven solution and a serverless solution. So I'll get rid of EC2 first, and with that, the servers being idle problem will also disappear. Let's see whether it actually does or not. And I'll bring in SQS. SQS will basically make the whole solution in a loosely coupled architecture way. It will be event-driven. Only when you get the request, SQS queue will build up. And whenever you get a request and the SQS gets triggered, it will process the message by calling a Lambda function, which is where all the logic that you wanted the EC2 instance to process, you will put it in a Lambda function, and essentially Lambda will process the data and will write it into S3. So this is what my solution would be: complete redesign of the application using an event-driven solution. I will use Amazon SQS and Amazon Lambda as the two components of this solution. Now let's see what we actually have in terms of options. So yes, we can see our option D is there, but we'll get to that at a later point in time. Let's go over other options first and figure out why those are not the accurate ones. The first one says use of EC2 in an auto-scaling group. Now, when you use auto-scaling group, yes, you will probably be able to scale and down the number of instances, but the instances still will be there and you will incur charges even when they're idle. So this is not going to help significantly reduce the cost. So that's gone. That's not a right option. The second one is build an application to use Amazon Lightsail with on-demand instances. Now, Lightsail, this is the new service, and we'll go over the documentation for this later on. Lightsail is good for small, predictable workloads, but it isn't ideal for scaling based on activity. So, like an option A, you'd be still paying for an instance when you're not processing data. So that's ruled out as well. Third one is use CloudWatch cron job to automatically run when EC2 instance when there is no activity. Now, this could reduce cost by stopping instances, but you are talking about manual configuration, and it may not be as responsive as the solution that we have already seen. So this is not an optimum solution. Point of call for choosing an option would be use a specific service that AWS created to solve a certain problem. Use automated solutions. Use a single service as opposed to multiple services. And that's how you should select your options. This is how you should narrow down your options and get to the correct answer. So option D is what the correct answer for this solution is, CV ruling out, which is to redesign the application to use an event-driven design with an Amazon Simple Queue service and AWS Lambda. So that's our answer. We've gone over it in detail. Let's go over some AWS documentation for this particular question. We have done a new service in this particular question, Amazon Lightsail. It's an Amazon's free virtual cloud server. It's get you started for free with Amazon Lightsail. And if you see key features, Lightsail gets you started quickly with pre-configured Linux and Windows application stacks with an intuitive management console. You will focus on your code, not on your bill. Lightsail bundles all the resources you need into a single simple price. It automatically configures networking, access, security environment. So it's basically your complete IT on a smaller scale in a black box. It lets you free from all the conversations around spinning up infrastructure, networking, etc. And you have one IT in a box in a virtual cloud server format. So please go through this link. I'll set up the link in the video description. That's it on this question. Question number 17. A business intends to use AWS to host a survey website. The firm anticipates a high volume of traffic. As a consequence of this traffic, the database is updated asynchronously. Organization wants to avoid dropping writes to the database housed on AWS. How should the business application be written to handle these database requests? So let's understand what do we have in terms of problem description here. We have a application is a survey website, and this survey website is anticipating high volume of traffic. As a consequences of this traffic, the databases are getting updated asynchronously. So you're getting surveys from the customers, and those surveys are not getting updated in a transaction mode, and there are delays happening to get the database update done. And obviously it's building up the traffic, and what's happening is you are getting missing the updates. Some of the updates are lost. So not all the surveys are getting updated in database. Some of the surveys are getting lost. Obviously, it's a loss of data from a customer input perspective. You probably do 100 surveys and you are only probably getting 80 surveys in the system, 20 surveys are lost, and that's not a good scenario. It's bad customer experience. Your application reliability is not good, and if customers know that after submitting a survey, their survey is still not captured, you are not getting any confirmation as a result of data getting lost, then obviously there would be bad trust for the website, which is capturing surveys, and you will have less and less customers even going onto the website to do the service. So the whole point of the website will be defeated. Now, what is the solution that we can have in this particular scenario? So as a solution architect, when you are given this opportunity to solve this particular problem, you have, as I told you earlier in earlier examples, you have liberty of doing either minor adjustment or redesigning the whole application. You are a solution architect. You are an architect. You are free to architect the application the way you want, as long as you are adhering to the requirements, problem description, and the constraints that you have been asked to stay within, which is generally cost, not to have unnecessarily operational overhead. So to stay within the cost, every solution that you develop, it has to be cost effective unless somebody's got infinite amount of funds. Every solution you develop should be less in terms of operational overhead, so it has to be automatic, it should be easy to maintain. And then obviously the solution technologies you select, there shouldn't be something that is excessive. For example, if you can use a simpler solution, a low cost solution for solving a particular problem, you should go for that rather than going for the highest tier product, which is super expensive in that tier. For example, this is just an example, not relevant for this particular problem. If you are going for some sort of database reporting solution, where you can do with Redshift Spectrum and QuickSight, you should stick to that because that's a simpler and cheaper solution, as opposed to going for anything like EMR or any other super expensive data warehouse solution or reporting solution. Going back to the problem we have here is servers are getting lost because of the high volumes, database is not able to cope. So what I would do in this case, again, something that I have probably done in previous question, considering because you are getting a lots of requests to be updated somewhere, I would like to go for event-driven, loosely coupled architecture. So what I would do, I'll get an SQS solution in place here, which will build a FIFO queue. All the requests of surveys could be captured in that queue. And when SQS queue would trigger for an operation for each of the requests that it is getting, and it will process the queue in a FIFO manner and update the database for each of the requests. No, this is not the complete solution. We have not figured out what is a compute service here. It could be Lambda, it could be EC2. I don't think that is the focus of this problem. So this is what I would do. Let's see what options we have in the actual question. And so we have option number 1 as configure the application to publish an SNS topic and subscribe the database to SNS topic. Now, this will not solve the problem. This might not even guarantee the delivery order. It would result into data consistencies in the asynchronous update. SNS is better for kind of broadcast notification, not data queuing.
And this is a data update situation. It's not about sending some notes out, sending some, information out for certain consumers. So this is not correct. So I'll rule this out. Option B is the second one. It says again another SNS topic option, where you are, instead of subscribe the database to the SNS topic, you are saying publish. Now this reverse flow, and again it doesn't address the main concern of guaranteeing right order and preventing drops during high traffic. So option A and B both using SNS. There's a subscribe model, there's a publish model. I don't think any of this is correct. So option B is also wrong. Option C and D, then it has the solution which involves SQS. Whereas, if you see option C, it's saying we need to queue the database connection. Now you cannot queue the database connection. You can queue the messages, but you cannot queue the database connection in a FIFO queue. So according to me, that's wrong, and hence we rule that out, C. And we're left with our option that we already discussed, which is Amazon SQS FIFO queue for capturing writes and then draining the queue as each write is made to the database. So you will build up the queue for all the service, and you will process each of those transactions one by one in a FIFO manner, and you will update the database. And that's your correct answer, which involves SQS FIFO queue for capturing the writes, option D. Before we move on to the next question, if you're finding this discussion and analysis useful and have not yet subscribed to this channel, then please hit that subscribe button for regular crowd certification updates. Thank you. Question number 18. On a huge fleet of Amazon EC2 instance, business runs an application. The program reads and writes items to DynamoDB database hosted by Amazon. The DynamoDB database increases in size regularly, yet the application requires just data from previous 30 days. The organization needs a solution that is both cost effective and time efficient to implement. Which solution satisfies this criteria? So you have an application which is based on EC2, and that application is writing data to DynamoDB on regular basis, and the database size is increasing day by day. However, the application needs only data from previous 30 days. So you don't need all the data all the time. At any point in time, you just need to go back to previous 30 days. But because the application has become so huge, obviously as the database increases, if you have more data there, you will have problems in querying. You may not get the right response to it because you're looking for a day which is 30 days old, and maybe you have their data which is worth 5-year old. So you're unnecessarily doing queries on that data, which is not even required for any of the operations. So that's the problem, and we need to solve this problem, and it has to be cost effective and it has to be time efficient. That's what the solution needs to be. So cost effective means don't do too many changes. Plus, later on, whatever solution you select, in case you do make a lot of changes, should not be super costly. And time efficient is you don't want to, again, do changes. So this is a hint that we're probably looking at some sort of minor config changes to do this. So exam tip for you: always select AWS service feature that is made for the given requirement. And based on amount of problems AWS has seen, they always keep creating solutions or update features in the services that they have to cater to majority of the scenarios. Now, storing data and then data getting accumulated and slowing down database. This scenario definitely has happened multiple times, and AWS must have some solution for it, which could be around some config parameter. And yes, there is one. But let's look for what that solution is. There is a feature called as time to leave. It's a parameter that you have in case of DynamoDB called TTL. And this is your magic bullet. Time to leave for DynamoDB is a cost-effective method for deleting items that are no longer relevant. TTL allows you to define a per item expiration timestamp that indicates when an item is no longer needed. And DynamoDB automatically deletes the expired item within few days of expiration time. And important bit here, without consuming the write throughput. So when it is doing deletion, that time it is not consuming any write throughput. That means, first of all, your data that you don't need disappears. You don't have to do any manual deletion. And because now you have a lighter database, so at any point in time, say you have 30 days data, that's what you need. The queries are going to be faster. So that's the overall solution scenario for you. DynamoDB AWS has given you a feature which allows, it's cost efficient because you're not doing anything else but just using another feature that is available in DynamoDB. It's time efficient as well because it's just a config parameter. You're not creating any new architectural block. You're not changing the architecture. You're not even having any manual intervention. The only bit you're doing is a configuration. And this is how that configuration happens. This is a page from AWS documentation. which I will give you a link for this in video description. Time to live, as we have said, it's a cost-effective method for deleting items that are not no longer required. And I can show you a page on DynamoDB console, which under additional setting, you can configure time to live parameter. So go through this documentation detail if you want to learn more about how to configure it. From an exam perspective, only thing you have to remember is if you have DynamoDB scenario and you need to delete data which is older than certain number of days, then you have a config parameter called time to live TTL, which you can use to delete the data that is no longer needed. And the good thing about this solution is it doesn't consume any write throughput. So that's our complete solution. And now let's look at the problem. We know the answer, what option we are going to select, but we'll eliminate the other options now to see why they are wrong. So the first one is, it says use an CloudFormation template to deploy the complete solution, redeploy CloudFormation task every 30 days and delete the original stack. Oh, this is going to be a very complex solution involving a lot of effort where you are creating and deleting the whole solution every 30 days. It's not the right way of doing things. I would cross this out. It adds a lot of complexity. It will involve creation of custom scripts. So that effort is needed and nobody does this. So option A is gone. Option B, use an EC2 instance that runs monitoring application from AWS Marketplace. Configure the monitoring application to use DynamoDB streams to store timestamp when new item is created. Use a script to run on EC2 instance and delete. Essentially, what it's saying, it's a very custom solution of creating scripts and deleting items which are older than 30 days. Now, there are two things here. This is not cost effective because you have to run the scripts and it is not a built-in feature again. And it will also take a lot of write throughput. So every time this deletion is happening, your application is going to slow down and you'll have to find a way, time of the day when your application is not being used, to actually use this feature. It's a very manual way of doing it. As we have seen, every time, wherever possible, you have to select an AWS feature that has been purpose built for it. Use something that is automatic, use something that is config rather than complete redesign. That's ruled out. Third one is configure Dynamo streams to invoke AWS Lambda function when a new item is created. Configure Lambda function to delete items in the table that are older than 30 days. So this solution is similar to B. Instead of writing scripts, we are saying let Lambda function do that job of deleting the items. Again, it's not a good solution. You are unnecessarily creating multi-step solution involving more services. Always use less number of services where possible. Achieve what you want to do to solve the problem with less number of services. That keeps the cost down, that keeps the complexity low. So option C is also incorrect, and the answer that we are looking for is option D. We have already gone over this concept in detail as part of the problem analysis and the solution overview. This is the correct answer for this particular question. Time to live is the attribute you will be using. It's a configuration and nothing to do with redesigning. So option D is the answer for this particular question, TTL attribute. And the exam tip, I have reiterated this multiple times. Always select AWS service feature that is purpose made for the given requirement. Do not go for a complex multi-step solution. And going even further ahead, do not select services which are, do not select multiple services, go for less number of services, go for cheaper services. So that's your full list of exam tip. I also have a summary table for why this option is a good one. So time to live, we have done this, but it's a summary now. You don't need any additional infrastructure. It's a built-in DynamoDB function. It's an automatic deletion. As you see, TTL will govern when the data is deleted, and it's not going to involve any DynamoDB bandwidth as well. Cost effective, you do not pay for the store. In fact, yeah, it's a cost effective comes from a two-way situation here. First of all, you're deleting the data in a cheaper way, and you're also not unnecessarily then paying for the storage cost that you could have paid for the data that is not necessary but sitting in the database without any reason. So that's another beauty of this solution. And the final one, it's very easy to implement. As you can see, it's just a config parameter. Very easy to implement solution. If you like, you can take a screenshot of this page and maybe keep it as notes. That's it on this question. Let's move on to the next question. Question number 19. A business is developing an application that is composed of many microservices. The organization has chosen to deploy its software on AWS through container technology. The business needs a solution that requires little ongoing work for maintenance and growth. Additional infrastructure cannot be managed by the business. Which step should a solution architect perform in combination to satisfy these requirements? And you need to select two options. So let's understand the problem and the answers here. Now, what you need to, in terms of keywords here, we need a container technology. And in terms of container technology, what you have ECS, you have Fargate as container technologies, and the typical features of these container technologies is you don't have to worry about maintenance and you don't have to maintain additional infrastructure. So I think the answer is going to be something around ECS and Fargate. But let's go through each options and let's eliminate few of these. We haven't seen these services earlier. I can see in option B and E, we have Kubernetes worker nodes as as the solution. Now, according to me, managing the Kubernetes control plane or worker nodes on EC2 would require infrastructure expertise and manual intervention. So that is not correct. Both the options have Kubernetes and EC2 instance, and we are looking to use serverless technologies. Now, Kubernetes is fine, it's serverless, but EC2 is not. So according to me, both option B and E are not correct because they are using EC2, and that means infrastructure expertise and manual intervention. So both are wrong according to me. So let's rule those out. Because we eliminated two options now, our complexity of this problem has become much more lower. Now let's see what we have. So option C, if you see, option C has ECS, which is obviously a serverless technology, but even that one is uh, using an instance launch type of EC2. Now, when you have a EC2 launch type, it still demands management by the business. So the combination of ECS with EC2 is not going to be the correct answer. Very easily, we were able to eliminate one more option. Option C is wrong, and we're left with option A and D, which is the correct answer. And if you closely look at option A is your Amazon ECS cluster. So that's a serverless technology. You don't have to manage infrastructure, easy to maintain. And option D, ECS service with Fargate as the launch type. So this is the right combination to satisfy all the requirements of the usage of a serverless technology using, and if you want a low maintenance, you don't want to manage any infrastructure, all those requirements are satisfied with option A and D. So that's your answer, A and D, ECS clusters with Fargate launch type. Let's look at how good is this option in terms of its features. So ECS cluster that manages and orchestrates container tasks across a group of EC2 instances of Fargate. It provides features like auto scaling, health checks, resource management. It reduces the need for manual intervention in managing container deployments and scaling. So that's your ECS cluster, which was one part of the solution. The second one is your Fargate launch type. It eliminates need to manage EC2 instance because now you're using a Fargate launch type. It scales automatically based on the specific desired task count. So auto scaling is great. Reduces infrastructure management overhead for the business as they don't need to directly manage any EC2 instance. So the launch type solves your lots of issues that we have been asked to solve in this problem. So combining both these EC2 cluster, ECS cluster and Fargate launch type, you are basically going for a serverless, low maintenance and scalable solution. And that's our selected option, option D. That's it on this question. Let's move on to the next question. Question 20. A business has implemented a MySQL database on Amazon RDS. Database support team is reporting delayed reads on DB instance as a result of increased transaction and advises installing a read replica. Which activity should a solution architect do prior to deploying this change? What is the situation here? We have a MySQL database on Amazon RDS, and what we are seeing is there are delays in read transactions on the database because there is an overall increase in the transactions. Now they have already decided to go for a read replica, so we're not solving a problem of what we should do. That's already being chosen. Read replica will be selected, but the question here is, before you actually implement the read replica, what all things one should do? First one says enable bin log replication on the RDS primary node. So enabling bin log replication is not something that you need to do manually before creating read replica. Amazon RDS for MySQL manages replication internally. It's not necessary to enable bin log replication explicitly. And I will provide you some links in fact, for all of these options, you need to go through some documentation if you want to understand in detail. But from an exam perspective, this is not an activity that you as an administrator has to do. It is done by RDS internally. So this is a wrong option. The next one, the option B says choose a failover priority for the source DB instance. Now, this is not relevant for creating a read replica. Failover priority is used for reliability, which is used in multi-AZ deployment, where two standby instances exist and their priority in taking over in case of failure is defined. So this particular aspect is for reliability, and it's nothing to do with this particular scenario where we are trying to create a read replica for improved read operations. So this option is ruled out for that reason. Then anything else we can eliminate? Option D. So it says create a global table and specify the AWS regions where the table will be available. Now this option refers to Amazon Aurora Global Database. It's nothing to do with RDS solution. So it's not relevant in this context. So let's look at the options. Option A, enable binlog replication on RDS primary node. Now binlog replication is not something that you need to do manually before creating read replica. Amazon RDS for MySQL manages replication internally. It's an internal feature. You don't have to do anything. So that's incorrect. And you may want to read a bit more on this. I'll provide you the detailed links for the information where all of this has been explained in more detail. Option B, choose a failover priority for the source DB instance. This particular option, failover priority, is to do with reliability and when you are deciding a failover priority in case of multi-AZ deployments. Now, this is not we are trying to solve here. We are trying to improve the read transactions by having a read replica. So this is not part of creation of read replica. So that's incorrect. And anything else we can eliminate. So we have ruled out two options. Option D, create global tables. Now, global tables is not a MySQL RDS database feature. It is a Aurora global database feature, and it is not relevant in this context. So we rule that out and we're left with two options. Then option C and option E, allowing long-running transactions to complete on the source DB instance and enable automatic backups on the source instance by setting the backup retention period to a value rather than 0. Now, you might say, why I'm so sure about it. I'll show a paragraph from AWS documentation about this. So this is a documentation from AWS for creation of read replica, and it talks about exact these two things. An active long-running transaction can slow the process of creating the read replica. So we recommend that you wait for long-running transaction to complete before a read replica is created. When creating read replica, there are other things to consider. You must enable automatic backup on the source DB instance by setting the backup retention to a period to a value other than 0. So these two are exact, lifted and put in the options. I will provide you a link in the video description for this particular page. But this is the rationale behind choosing those two options, and it does make sense as well, especially for option C, which is you cannot take a read replica while the transactions are going, because if you do that, if there is a long running transaction and you start doing replica, you're not going to be able to capture the transaction that is ongoing. You will capture it in a halfway, and you don't know what will be the outcome of in an incomplete transaction on the status of the database. So that's it on this question.
This is Exam Tricks and Tips. You're watching AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.